Hello friends, welcome to Ch-8. In this video, we'll be discussing trigonometry. So let's start. Now under the head of trigonometry, what we are going to discuss in this video would be trigonometric ratios, trigonometric identity and trigonometric ratios. When I say, I mean of complementary angles. These are the three broad things that we are going to discuss. Yeah. Now, while we are doing this, the objective would be, when you're learning, the objective would be have fun with learning. Yeah. And we call this as fantastic. So let's start. Okay. So now most of the trigonometric ratios, when we talk about, we take a right angle triangle. So this entire thing is based on a right angle triangle. So the very first thing that I am taking here is I am taking a right angle triangle such that there are three vertices x, y, z. Please focus only on this triangle in the very beginning. Now when I have taken these 3 points, these are three vertices, the right angle is at y and I have assumed angle x, z, y as theta degrees. Therefore, the remaining angle which we are talking about. So, what is the remaining angle here? The remaining angle here is y, x, z. So, we know that the sum of the three interior angles of a triangle is equal to 180 degrees. So, 90 plus theta makes it 90 plus theta. 90 degrees plus theta degrees, and thereafter we subtract it from 180 degrees, which is why the measure of the angle that we get here, which angle are we talking about? We are talking about angle yxz will be 90 degrees minus theta degrees. Once we have done this, we need to understand that in this right angle triangle, xy is the perpendicular, the length of which I have taken it as capital P. So the length of this line segment xy is capital P, which is known as the perpendicular. The length of the line segment YZ is B, capital B, which I have taken it as the base, and the length of this line segment XZ is known as the hypotenuse of a right angle triangle, which I have taken it as capital H, right? The measure of this line segment. This is the first part. Second thing which you are expected to know in a right angle triangle is the sum of the squares. The sum of the squares of the perpendicular and the base is equal to the square of the hypotenuse, which I have already taken here. Right. The third thing. So this is the first. We were talking about the terminology and their lengths. Then we talked about the Pythagoras theorem, which is this. The third thing that you need to understand here is which comes from triangles, the law of inequality inside the triangles. So what is the law of inequality inside a triangle? The law of inequality says that the sum of any two sides is greater than the third side. And the difference between the any two sides is lesser than the third side. This is the law of inequality, using which we'll be able to say that the length of the hypotenuse in a right angle triangle would be the greatest. And thereafter we'll make two cases here. What are the two cases? Now, when I know that the length of the hypotenuse is the greatest here, in that case, the length of the perpendicular arm and the base arm may be equal. In that case, the triangle becomes an isosceles triangle, which we have taken here, which is just like saying 45 degrees and 90 degrees. Or the next case here is we can get a scalene triangle, and we know that scalene triangle is a triangle in which all the three lengths are unequal. So when we are saying P is not equal to B, in that case, the basic thing that we need to understand is in a scalene triangle, P is not equal to B and B is not equal to H. And the first case that we had taken here was P is equal to B but is not equal to H. This is the thing that you need to understand. So these are three things. And you will see in trigonometry, we'll be using coordinate geometry, some concepts of coordinate geometry, we'll be using geometry throughout. So your basic concepts of geometry need to be clear when you are trying to understand trigonometry. And when we said that we are going to make it fantastic, that means I basically want that you should not be mugging up anything Because when you turn over the chapter of your book, maybe NCERT or any other book, you should not be found mugging up all these things, because we are going to make learning really fun. Right? Okay. So these are the first 3 points that I have talked about. Next that you need to understand is what are the possible ratios that you can get from 3 sides. So that means ratios are going to be used immensely when it comes to trigonometry, which is why we are talking about trigonometric ratios. So you need to understand, when I talk about a trigonometric ratio, how can I get a ratio from 3 different sides? These are 3 different sides. So what I have done here is, remember the thumb rule. What is the thumb rule here? PBH. So I'm using the thumb rule PBH. Next time and onwards, whenever I'm talking about the right angle triangle, I'll use the terminology PBH. PBH means I am talking about this order. You need to start off with P, then come down to B, then come down to H. Why am I suggesting this? In few minutes you'll understand. So how do I get a ratio? I need to have a numerator along with the denominator. That is how I get a ratio. To be more specific, that is how I get a fraction. And fraction and ratios, they go hand in hand. So in order to get a trigonometric ratio, how can I get it? So take the numerator as PBH. How many cases have I made? 1, 2, 3, 4, 5, 6, 7, 8, 9. And it was very easy to make these cases. How? You will take the numerators as PBH, right? Once you have taken the numerator as PBH, in all these 3 cases, you will take the denominator as P only. In the next 3 cases, you will take the denominator as B only. And in the final case, you will take the denominator as H only. So you can just count 3 cases with denominators as P, 3 cases with denominators as B, which is base, and further 3 cases wherein the denominator is H. And then the numerator would be PBH in this order. There is a reason why I have taken the thumb rule as PBH. So once you are able to do this, you will see that there are 9 blocks that I have made here. So what are the values? So you will see, you'll experience something very interesting. The very interesting part is, you along this diagonal, you will get the value as 1 only. Along this diagonal. Correct? Now, when I talk about the other diagonal, when I talk about this is just like understanding. And when I talk about this diagonal, this is just like saying cosec is just the reciprocal of sine. Right? And then thereafter we can talk about, now when I treat this as a diagonal, this as a diagonal, so we will say that these 2 trigonometric ratios of functions are reciprocals to each other, and these 2 are reciprocals to each other. So please remember the order. So what is the order I am talking about? If I go along this diagonal, then this diagonal, and then this diagonal, you'll experience something very different. Now, the next thing which is important here is, how much is P by P? 1. How much is B by P? Now, this is how you make. So these are the values that have been already decided in advance. What are the values? Let us first talk about this column, the first column. So P by P is equal to 1. P by B is known as tan theta. At the same time, P by H is known as sin theta. Now, when I talk about this column, now once I know P by B, this becomes the reciprocal of P by B, which is B by P. This is known as cot. So the reciprocal, this is what I was talking about. If I talk about this diagonal, these are reciprocals. If I talk about this longest diagonal, this diagonal, these are reciprocals. If I talk about these diagonals, these are reciprocals. I hope you would have understood this. Now, once you have understood this, what are the 3 things? There are only 2 things that you need to remember from here. So if I remember this, and if I remember this, can I get the values of cosec if I know that cosec is the reciprocal of sine? Yes. Can I get the value of sec when I know that sec is the reciprocal of cos, which is cosine? Of course. Can I get the value of tan theta? Yes, tan theta is just like saying sin theta upon cos theta. So the point to be understood here is, tan theta can be written as sin theta upon cos theta. which is cosine theta. Right? And once I know sine and cos, I can get tan. Once I know tan, I can get cot. I mean, pun intended, you will not get cot here. What I mean to say is cot theta. Okay. And at the same time, if I know sine theta, can I get the reciprocal of sine theta? Had I known that the reciprocal of sine theta is cosec theta? Yes. And if I know cos theta, if I know the value or if I know whatever about cos theta, can I get the value of its reciprocal? Of course. That is why I say that this thumb rule of PBH is very important. This is how trigonometric ratios are launched. Now, next thing which is very important here is, so this was using PBH for trigonometric ratios and thereafter giving them specific names like sine, cosine, tan, cot and so on. Now, how to use this Pythagoras theorem? Let us experience this now. So the first part is over. Now the second part is focusing on the Pythagoras theorem and thereafter establishing some trigonometric identities. Now before I go ahead establishing some trigonometric identities, you need to understand what is an identity. So identity is when I say a left hand side value is equal to a right hand side value. This is known as an identity. For example, if I am able to establish tan theta is equal to sine theta by cos theta, this itself becomes an identity because the LHS, which is left hand side value, is equal to RHS value, which is right hand side value. So another is if I write 1 is equal to 1, or if I write 2 is equal to 2, or if I write 3 is equal to 3, this is just like saying these are identities. So you need to know the definitions of the basic terms before you go ahead understanding the next level. Okay, so what is the next level? We know that h square is equal to a square plus, h square is equal to p square plus b square. This we already know this using Pythagoras theorem. Okay, so what I am suggesting here is, let us say this column A, this is the first column, I am taking it as A. The second column I am taking this as B, and the third column I am taking it as C. And what am I asking you to do? Just understand it like this, that A square plus B square is equal to C square. Please relate. I repeat, I am asking you, I am suggesting that you should take, this is P. Please understand it as P. Understand this as capital B. Now when I know P square plus B square gives me H square, I am just suggesting that take this column value as A, take the second column value as B, take the third column value as C, such that let's say P square, which is A square, plus B square, which is small b square, is equal to C square. From here you will be able to establish the identities. Now what am I asking you to establish, and why am I making this? You need not, why am I deducing this? Because you need not mug it up. Had you known this, and thereafter you can establish it by taking their squares. So this is just like saying, if I take row 1, this row, so can I say 1 square, which is 1, plus cot theta whole square, which can be written as cot square theta. So another point to understand here is, if I am saying sine theta degrees whole square, this has to be understood as sine square theta. Please bear this thing in mind. Okay, so 1 square plus cot square theta will be equal to cosec square theta. The same thing I'll say here, tan square theta plus 1 will be equal to sec square theta. And finally sine square theta plus cos square theta will be equal to 1. So this really becomes fun. And nobody is expecting you to mug it up. You just have to understand it fundamentally, and if you go ahead like this, this is the trigonometric ratio. With the help of ratio and the Pythagoras theorem combined together, you are able to get these trigonometric identities. Next, we will talk about the values of sine theta, cos theta and whatever after this. So, and then we'll talk about complementary angles, and then we'll talk about some specific values like 30 degrees, 60 degrees, 90 degrees and so on. But before that, what I'm suggesting here is, I have taken this triangle and I have made a symmetric triangle. So what I'm assuming here is, let us say this is my x-axis, this is my y-axis, and this is the point of intersection of both the axes, which is 0, 0. So if this length is P, this length will also be P. I have taken a point X dash. I have drawn the similar triangle. So what am I suggesting? I'm suggesting you to take the water image. The water image is, water is here, and I'm asking you to look down. So everything else remains the same except for I have taken one more point here. Let's say this is X dash. And the length of XY is equal to, so we have assumed that the length of XY is the same as YX dash. This is what we have assumed here. And we'll make this really a fun, if you are able to understand this. So once you have done this, so if I have to understand this with the help of coordinates now, I can say that this point can be written as 0, B, capital B. This point can be written as, this point will be written as B, 0. This point will be written as 0, P. And this point will be written as 0, minus P. Why minus? Because this is going on the other side of the x-axis. You're going down. And as you go down from here, you start getting negative values. So instead of taking this as P, this entire length, this is just figurative. I've taken it as minus P. Why have I taken it? We'll understand it in few minutes. Similarly, if I've taken this angle as theta degrees, and I'm taking a symmetric, I'm just taking a water image. So I'm suggesting that take this value, take the angle X dash ZY as minus theta degrees. So we know that this is minus theta degrees, this is 90 degrees, 90 plus this makes it 90 minus theta, and you subtract it from 180 degrees. So in that case, the measure of the angle Y, X dash and Z comes out to be 90 degrees plus theta degrees. Now, why is this being done? This is being done so that you can establish the formulas. Which formulas? Complementary angle formulas of sine theta, cos theta. And once you are able to establish the formulas for sine theta and cos theta, as discussed earlier, you can deduce tan, you can deduce cot, you can deduce cosec, and you can deduce sec if you know the relationship between sine and cos and the others. Correct? So, now, taking one trigonometric ratio from here. So, I'm just taking these two trigonometric ratios. One is P by H is known as sine theta degrees. Can I say sine theta degrees? And if I take sine of minus theta degrees. Now, sine of minus theta will be the same as perpendicular upon the hypotenuse. But this perpendicular is minus P by H. And I have to make it as P by H. So, I'll multiply it by a minus. So, minus into minus gives me how much? Plus only. So the point to learn from here is, can I say sine of minus theta will be equal to minus sine theta? This is the point that I am trying to make. And at the same time, can we find out the value of cosec of minus theta? Now cosec has nothing to do with the perpendicular. Cosec has something to do with base and hypotenuse only. So the value remains the same. How much is cos of minus theta degrees? It will be the base upon the hypotenuse, which is the same. So from here you will be able to establish that cos of minus theta degrees is equal to cos theta degrees only. And you just don't have to mug it up. Just remember these figures, you yourself will be able to deduce it anywhere and everywhere. And my suggestion is, whenever they are asking you to prove something, which is just like saying that you're trying to establish a trigonometric identity, just substitute these values. Just use as P upon H for sine. Use P by B for cot, for tan. Use B by H for cos, and so on. This is what I'm suggesting from my side, so that it becomes interesting for you and you don't have to mug up anything. Similarly, when I know it is P upon H, from this triangle, can I say cos of this angle, which is 90 minus theta, is equal to base upon hypotenuse, which is P upon H only? And from this triangle, can I say cos of 90 plus theta is equal to base upon hypotenuse, which is minus P by H? But this value should come out to be P by H, which is why we will say this is minus cos 90 plus theta degrees. Now, this I have explained you in detail. From here, you know the relationship now. What is the relationship? Sin theta is equal to cos of 90 minus theta. Cos of 90 minus theta is just like saying minus of cos of 90 plus theta, or any other thing. You can have so many comparisons here. How many comparisons you can make? 6. 3, another 2, and finally 1. And the same thing you need to establish here for b by h, which I have already done it for you. But this you can take it as a take home so that you can practice it on your own, whatever I have explained here. And if you have any doubts, you can always put it as comments so that I can explain it to you. What did we do and how was it done? Finally, so from here, can I get the value? If I know sine and cos, can I get the values of tan? Of course I can. So how much is tan of minus theta? Now tan of minus theta degrees is just like saying sine of minus theta degrees divided by cos of minus theta degrees, which is just like saying minus tan theta degrees. So this is what I was trying to say. If you know sine and cos, you can find out any other value so easily. Okay. Coming down to the final discussion. So what is the final discussion now? So as discussed, we had taken two triangles. One is 45, 45, 90 and the other triangle is 30, 60, 90. But before we do that, so this triangle is a scalene triangle and this triangle is what? It is an isosceles triangle, which we already know. But before we do that, let me just use these two. Which two? So that we do not have to mug up the values of sine 30, cos 30 and so on. Okay. So can I say sine 0 is equal to cos 90, putting the value of theta as 0? Yes. Can I say sine 30 is equal to cos of 90 minus 30, which is cos 60? Yes. So which is just like talking about, this is nothing but we are talking about this triangle only. And this sine 45 is equal to cos 45 is just like talking about this triangle only. Same, this and this are the same except for the sine. Now you are taking sine of 60 degrees, which is equal to cos of 30 degrees. And this is just like, so these are kind of same, synonymous with each other. These are kind of same. And this comes as a separate entity. Right? Okay. Now, how do I understand sine of 0 degree? Now, we know that sine is nothing but perpendicular upon hypotenuse, and we have already done numbers wherein I know that a number, rational numbers, are nothing but which are written in the form of p by q such that q cannot be equal to 0. So, using the concept of rational numbers, I know that the hypotenuse can never be equal to a 0. We know that in a triangle, none of the sides can be equal to a 0. But when I'm expressing it in the form of a fraction, I'll say the denominator will never be equal to a 0. It is only the numerator which can take any number, any negative number or neutral, which is 0 or a positive number. So once I know this, if I can just understand it with the help of the diagram. So now this is theta. So let's say you're holding this from this end and now you're decreasing the height. So let's say you're holding it, this becomes the hinge. And now this is just like, let's say there is a ladder and you're taking the ladder downwards. Now when you're taking the ladder downwards, till the time you make the ladder lie on the base. This is just like a ladder and you're making the ladder slip. Till the time it slips onto the base. So the moment the ladder slips onto the base, you will say that the hypotenuse in a certain way becomes the base only. And the height becomes 0. Height means perpendicular, which is just like saying that theta becomes equal to 0. So can I say perpendicular becomes equal to 0? And let me put it under the head of a root. Right? Now, before we go ahead, let us talk about this triangle. So when I talk about this triangle, it is just like saying the base is root 2, the perpendicular is root 2, root 2 square is 2, root 2 square is 2, 2 plus 2 is just like saying 2 square. So in this case, let's say the length of the ladder is xy, the xy that we had taken here. So here it was xz. Let's say here the ladder here is xy. So the length of the ladder here is 2. So I am fixing the length of the hypotenuse as 2 in all these cases. You know that sine is perpendicular upon hypotenuse. And what will we vary now? We just vary the angle. So we started off with 0 degrees, which was just like saying slipping the ladder onto the base. And now raising it by 30 degrees, raising it by 45 degrees, raising it by 60 degrees or raising it by 90 degrees. Now when you raise the ladder by 90 degrees, it's just like when you are saying that the ladder length becomes equal to the perpendicular length of the triangle, is what you are trying to say. Okay, so in this case, hypotenuse we have made it as a 2. So the point that I am trying to make here is, what is the next integer that comes after 0? 1. Let's put it as under root of 1. Next integer that comes after 1 is 2. Just keep it as under root of 2. Next integer that comes after 2 is 3. Next integer that comes after 3 is 4. So it becomes very interesting because the perpendicular length varies from a root of 0 to a root of 4. And why is it varying to a root of 4 is because this is isosceles. Now, so why is it varying to a root of 4 is just like you're trying to make the perpendicular length equal to the length of the hypotenuse. So which means sine, so we know that this is 2 by 2, which is 1. This becomes 0. This is 1 by 2. Finally, this can be taken as 1 by root 2. This is root 3 by 2. So even if you forget these values but you remember these, it becomes very easy for you to remember all these things. I hope that you learned something different today. And if you feel that something very, very informative has been discussed with you, please do not forget to like, share and subscribe to our channel. If you have already done so, please click on the bell icon so that you can start receiving updates from us regularly. If you want us to do some videos on some specific topics, please put it in the comment section so that we can do it for you. Thank you so much. Until next we meet, goodbye.